Hi everyone, I decided to do a video for Quiz 9 notes. I'm not sure how long this is going to take. I might have to do two 15-minute videos. I'm hoping not, but just because of the length of the questions, or just because of the length of the quiz with it being 20 questions. But anyway, let me dive in, and I'll do my best to try and see if I can squeeze this into one. And if you need to replay along the way because I'm speaking too quickly, just please feel free to do so. Okay, so first couple of questions ask about what type of the objective of the study, and they talk about estimates versus tests. Well, if you see things like statistically significant or cause and effect type things where there's a clinical trial or an experiment, you would see test. In this case, they're not talking about a test. They're just investigating a relationship. So we're not testing this. We are actually estimating. And so what they found is that the mean, see the word mean here? The mean bone mineral density. And so I want something with the word means in here. And they're comparing two means. The mean of the bone density with someone who drinks soda every day, daily cola intake, or someone who consumes less than one serving of cola per month. And they want to see if it has some impact on your bones. So in this study, there is no proportion. I know there's percents here, but those percents are just actually they're referencing the difference in the means. That's it. So this is the one we want for this question. All right, let's take a look at the next question. All right, so in this one it says Americans in this decade are less likely than in the prior decade to say that they want to lose weight, with the average dropping from 59%, definitely a proportion because it's the average of people who are answering in the affirmative, to 53%. So again, this is proportions. So the percentage of Americans wanting to lose weight is now back to where it was in the late 90s, but is still well above the 35% that the Gallup measured in 1950s. They don't say they're trying to compare it. They're just trying to estimate. So remember percents. So this is going to be a proportion. There are no means in this question, so you can get rid of means immediately. And because you don't see the word statistically significantly different, they're just telling you, what the new data is. We would just call it estimated proportion. Okay, so I'm going to pause as I flip to the next slide. Okay, so the next question is talking about genetically modified foods, and in the Pew Research report from January 2015, 37% of adults, again, this is a proportion because we're talking about the proportion of American adults, say that genetically modified foods are generally safe to eat. The margin of error for this was a 95% confidence, so this is a confidence interval, and the margin of error is how much wiggle room we need. So this is my margin of error right there. And you'll see that when they do voting and other techniques. So the question says, what does this margin of error tell us about how we would interpret the survey results? Now remember, I've only asked so many adults in this survey, probably close to 2,000. Well, that's not everybody, so I have to make some wiggle room in case for sampling variability. So let's read some of these answers. We are confident that 95% of the responses are within 3.1 of the population proportion. There is no population proportion in my confidence interval. My confidence interval only has sample proportion and margin of error. So this one doesn't make sense. So let's get rid of that. We are 95% confident that the population proportion, that's what I'm trying to estimate. So this is what I'm trying to estimate. Trying to figure out what is generally people's opinion about genetically modified foods. So I'm trying to estimate is within 3.1% of this. This sounds perfect. So I'm going to put this as, but let's read the other answers just to see why they're not correct. We are confident that the population proportion is within 3.1% of the sample proportion of 37%. So although that sounds good, they were missing a key number. They were missing how confident. So to be perfectly clear, you have to say the 95%. And that's why this one isn't counted. And then the last one says we are 95% confident that the sample proportion is off by 3.1%. That is not at all what it's saying. The sample proportion is in the center of this confidence interval. And then you would add and subtract 3.1%. And so we're just saying based on the sample proportion, we're allowing 3.1% variability or wiggle room to account for sampling variability. It's a little complicated, but essentially, if you always start off a sentence with we are 95% confident, that's going to be the one that you'd want to select. And of course, if they're addressing the population proportion. All right, I'm going to pause as I go to the next one. All right, for this question, you just have to calculate the confidence interval. And it may be one of the easiest ones in this quiz if you know how to use the template. So they basically say that the Family Foundation poll conducted from January through March 2015, pardon me, 20% of women ages 17 to 16 who attended college during the last 4 years say they were sexually assaulted. The poll surveyed 514 random selected individuals. So this is my sample size, that's my N. This would be my P hat. But according to my template, I can't put the P hat into the formula. So I'm going to have to figure out how many women actually said they were out of the 514. So you'll see how we'll do that. So it says, what is the 90% confidence interval? That's another number I need. So let me pull up my template here and see how to calculate this. So let's go with... Okay, so the most challenging number to get will be this number of successes. So we have to do a little bit of work. So we have to take the 20%, okay, that was our proportion, and we have to multiply it by the sample size, 514. You'll see that you have to do that in the homework on a couple questions as well if you haven't done the homework yet. Hopefully you did the homework before you're taking the quiz, so you're kind of comfortable with that. In Excel, I can actually do that right inside the cell. I just have to put in an equal sign. So let me show you how that would work right in this cell. If I did equals 20% times 514 and hit enter, it'll tell me the sample size, I'm not sorry, the sample size, the number of successes. All right, and then the sample size would be 514, and my confidence is 90%. And you'll see that as soon as I hit enter on the 90%, my interval is 0.171 and 0.229. So let's take a look, and that's that answer right there. So this is potentially the easiest one. The only thing is you have to convert this proportion of women who said yes into the number of women who said yes. That's it. All right, let me pause while I do the next one. Okay, so for this question, it says we know that a narrower confidence interval gives us a more precise estimate of the true population proportion. So which of the following could produce a higher precision in our estimates for the population? One of the ways that we can actually decrease the width of our confidence interval is by increasing sample size. So we can get rid of this one. Decreasing sample size just doesn't even make sense. That means you're asking less people to be more precise. That's counterintuitive. So we can get rid of those. So these two are gone. Now let's do the other two. So do we want to select a lower confidence or a higher confidence? Okay, let's take a look at this normal curve down below, which is essentially what a confidence interval would show us. If I wanted to find the more precise by finding something that's narrower, notice 68%. Now, we would never do a confidence interval of 68%, but I'm just trying to demonstrate how narrow that is, compared to 95 and 99.7. So if I wanted to do a confidence interval that was narrower, I would want to, and this sounds perhaps counterintuitive, I would want to lower the confidence. I would want to go from 99 to 95 would be narrower, but 95 down to 68 would even be more narrower. And thus my answer would be more precise. Now, is my answer just as probable of containing the population proportion or the population mean? No, I only have a 68% chance. We're only 68% confident when it's that narrow. So, at any rate, lower confidence and increased sample size are the two you want to actually have a higher precision. Okay, next question. And for this one, it's asking college alcohol and drug use. And they basically surveyed people again, and they found 56% of adults ages 17 to 26 who attended college during the past 4 years say that alcohol and drug use was a big problem. Okay, but remember the 56% is just based on the sample, so we have to give it a little bit of wiggle room. So that could be anywhere from 53% to 59% to represent my 95. So as I told you, we want to always start this with something like we are 95% confident. So if I were to use that for this problem, we can get rid of these two. But now we're down to two questions, and which one is the correct one? Well, it says we're 95% confident that the proportion of the sample, well, it's not 95% confident the proportion of the sample. The proportion of the sample is 56%. That's a 100% chance that it's within this interval. So we don't want to use the proportion of the sample. We want to basically make an estimate for the proportion of all adults of adults, should probably say all adults, who attended college during those past 4 years. We're trying to make an estimate for everybody who did this and what their true opinion would be. So what is the true proportion? And that's why this one is the answer. Okay, for this question, it's asking, or it's telling us the makers of Mini Oat cereal have an automated packing machine that is set to fill boxes within 24 ounces of cereal. At various times in the packaging process, we select random samples of 100 boxes to see if the machine is actually filling the 24 ounces it's supposed to. Which of the following is the appropriate null hypothesis? So if you remember, the null hypothesis is the background condition. It's what we assume to be true. So in this case, we're assuming that the mean is equal to 24 ounces. And if it's not, the alternative would show us. So the alternative will use the 100 boxes to say that it's different. So the alternative here, I'll write it over here even though I usually write it underneath, the alternative would be mu does not equal 24. All right, so in this case, the machine fills the boxes with that is considered our null hypothesis. The machine is not putting enough cereal in the box. The average is less than. That could be an alternative. So that would be an alternative with mu is less than 24. The machine is not filling boxes. The average is not. And this is also a possible alternative depending on which side we're trying to check. So I would write it like this, not equal to 24. All right, so I hope that one helps on this question. Okay, for this one, a tire manufacturer has a 60,000 mile warranty for tread life. The company wants to make sure that the average tire lasts longer. So that's telling me greater than or more than 60,000 miles. So basically what they're going to do then is they're going to test the tires to see what happens. Well, they took a test. This is the alternative. This is the data or the evidence for the alternative, 250 tires, and they found out on average they lasted 64,500 miles. Okay, but these numbers I don't need until I want to do the conclusion. So my null would just be the average is 60,000. My alternative, because I want to see if they last longer, is greater than 60,000. All right, so the mean tire life equals 64. That's not even part of this because I'm actually looking at that as my base. So this can't even be used. Anything with 64,500 shouldn't even be considered. So this one says the mean tire life is less. Nope, I want longer, so I don't even want that one. I want this one because it's greater. And it says the proportion that the tires are worn out after 60,000 miles is greater than a half. That doesn't even make any sense. So we wouldn't even consider that one. Okay, as you can see, the trend in this quiz is for some questions to be mini novels here. So again, we have a lot of reading to do. A tire manufacturer has a 60,000 mile warranty for tread life. The manufacturer considers overall tire quality to be acceptable if less than 5% are worn out at 60,000. So what this is saying is basically it's kind of like defective rate. If the defect rate is 5% or less, we're good to go. The manufacturer tests 250 tires that have been used for 60,000 miles. Okay, so that's important. Have been used for 60,000 miles. And they find that 3.6% of them are worn out. So this is my evidence against it. Or this is my evidence for my alternative. So here we go. So they give us the null and alternative. It's a little bit wordy, but it basically tells us what we need to do. And then down here, we got to figure out which one is the correct thing. What is it asking? What assumption about the sample underlies the hypothesis test? Well, we have to make sure we're getting a sample that matches the population. Well, what is the population? The population is 60,000 miles, and of them, 5% are worn out. So we're assuming that 5% of the population would be worn out. That's what we're trying to test. So down here, if I come through this and you look at some of the, remember, you don't want to use the data from that we just collected, okay? And so you don't want to use that one. But if you come down to the last one here, it says the sample comes from a population with 60,000 miles where 5% of tires are worn out. That is your best guess because that's going to represent the population in question. Okay, we got through 9 questions, so I will pick up on the next video for the next questions.